Hi everybody, my name is Kelsey Beach. I'm an education coordinator with Ohio Energy Project, and thank you for joining me in my dining room today. We're going to be doing an elementary energy efficiency lesson. Today we're going to be doing lesson 4 that's on insulation, heating, and cooling. So to begin, I'll talk about the materials that we're going to need, then I'll get into a little bit of background info, and then we'll start the procedures for the investigation. If you do have your student guide, this is going to start on page 39. It looks like this. So you can turn there, or if you have it digitally, you can access that as well. You are going to need today different materials that are insulators. So I want you to kind of scrounge around your house, in your kitchen, in your drawers, and look for materials that are good insulators. Yours may look different than mine, and that's totally fine. So for me, I have some bubble wrap, I have a wool sock, a cotton sock, and some aluminum foil. And you are going to want to wrap your containers with each of these materials. And then you're going to also need a thermometer to test the temperature. We're going to take the temperature of water that's poured into each container. If you don't have 4 thermometers, that's okay. We can make it work with just one. And if you can't find lids, you could use some plastic wrap over each one. So don't worry if it doesn't look just like mine. You can make it work at your home as well. In addition to the materials and the containers and the thermometers, you also need some hot water. So please make sure that you have an adult who can supervise you when you're using that hot water. And then finally, you're going to need a timer. So those are the materials that we need. Again, if you don't have the exact materials, you can still make this investigation work at your house. So a little bit of background information before we get started. Today we're going to be thinking about energy and how certain materials can speed up or slow down the transfer of energy. So insulators, what we're going to be testing today, are materials that slow down or stop the flow of heat energy, while conductors can move heat energy very well. So when we're thinking about heat, we have to understand that heat seeks balance, like all things in nature. And heat always flows from areas of higher energy to areas of lower energy. So think about if you were going to pour hot water into a cold bathtub. The hot water molecules have more energy, and they crash into the cold water molecules and give them some of their energy. They transfer it. And this is what changes the temperature of the water. So taking this concept, I want you to think about your house and if you've ever felt air leaking in or out of your house at certain places. So maybe around the doors or the windows or maybe in your attic. So if our homes are well insulated, air is not going to be leaking in and out of our homes, and we can save on our heating and cooling costs. So heaters and air conditioners use more energy than any other system in our homes, and about half of your family's utility bill goes towards heating and cooling. So with all this in mind, today we're going to test these materials for their insulating power, and we're going to think about how we can apply this to our homes to make them more energy efficient. If you're looking for a little bit more background information, on pages 37 and 38 of your student guide, you can find some activities about insulators and conductors, and this will also help you to get into the investigation. So to get started on our investigation, we want to think about the question that we're going to answer and make a hypothesis for what we believe will happen in our experiment. So the question that we're going to answer today is, are certain materials better for insulating than others? So if you want to pause the video right now and make your hypothesis based on the materials that you chose, please do so. You want to explain what material you think will be the best insulator, second best, third, and which one you think will be the worst and why. So if you want to pause the video, you can do that now. So the procedure for the experiment, what you're going to do is you're going to get your hot water and make sure that it's not too hot if you have a plastic container, because you can melt the container. So ideally it will be 120 degrees or less. So you're going to get your hot water and you're going to pour the same amount of water into each container. And then you are going to take the temperature of each container. And this will be your 0-minute temperature if you're looking at your student investigation page on page 39. So we want to get a kind of a baseline temperature for each container. Now, if you pour your hot water in, so I'm gonna pour about a half a cup of hot water into my container. Okay, so after I've poured the water into each container, you're gonna take your 0-minute read. And I would encourage you, if your temperatures in each of your containers are fluctuating a lot, and say one is reading like 115 and the other is reading 80, kind of wait for the temperatures to even out and then record your 0-minute temperature read. This will just help us get more consistent results. So after you do your 0-minute read, then you're going to start your timer. And for every minute, for 10 minutes, you're going to record the temperature of each container. So for example, I'm going to wait 1 minute, and then I'm going to record the temperature of each of my containers. And then on the 2nd minute, I'm going to do the same, and the 3rd and the 4th, and so on until you are at 10 minutes. And then you're going to decide which is the best insulator. And to do that, you are going to record the change in temperature for each container. So for example, if my bubble wrap, let's say my 0-minute, my starting temperature was 100 degrees, and my final temperature, my 10-minute temperature was 80 degrees. I'm going to subtract 100 minus 80, and I'm going to get a number, and my number is 20 degrees Fahrenheit. So my change in temperature is 20 degrees for this bubble wrap. And then I'm going to do the same thing for each of my containers. And to find out which one is the best insulator, we want to see which one had the least amount of change. So which one had the smallest change in temperature. So that means that whatever container had the least amount of change meant that it was able to insulate the container and keep the heat energy in rather than letting it out. And so that is what a good insulator does. It slows down the rate of energy transfer. So based on what materials you use, you will have some different results. And what we encourage you to do is that after you've done the lesson, you might want to do this lesson a few more times and see if you get the same results. And that will give us more reliable information as to whether or not our experiment is being done accurately. So another thing that we encourage you to do after your experiment is think about any variables that could have impacted the results. Variables are things that happen in a science experiment that can change the intended results, and scientists try to eliminate or get rid of these variables so that they have the most reliable data and information. So one example of a variable is I made sure that all of my containers were wrapped on the bottom, right? Because I didn't want any air to leak out of the bottom of my container. So let's say this obviously is wrapped on the bottom, but let's say my foil, I had no foil on the bottom of my container. Well, that would be a variable that could have changed the results. So think about any variables that could have happened in your experiment. And if you do the experiment again, try to eliminate those variables to get the most reliable results. So to conclude the lesson, there are some assessment and conclusion questions on page 40 of your student guidebook. We encourage you to check those out. But also we want to think about your own home and where you can better insulate areas in your house to reduce air leaking in and out. If you do have your student kit, you have some materials in there that you can use to insulate your home. So if you want to make sure that an adult is with you when you install those, but it is a great way to save on our energy costs and our utility bills and make sure that our homes are energy efficient. So thank you so much for watching.